Okay, so let's talk about what happens when you deploy an application. Or in Cloud Foundry terms, you do a CF push. So CF push is the command that you use to deploy an application to Cloud Foundry. And when you do a CF push, you typically specify either on the command line or in a manifest file some information about the application. So when you do a push, the first thing that happens is that information gets stored in a database. And so it's things like the name of the application, the amount of memory to allocate to each application instance, the number of instances, the route to use for your application. And so that information gets stored in a database. And actually, before that even happens, it does a little check and it looks and it says, well, is there an application already in this space with this name? If there is, great. It'll actually just overwrite it. It also looks at the route and it says, is this route actually available if this is a new application? And that's to ensure that you don't have any collisions with other applications for other users in other spaces or something like that. So once that information is up there in Cloud Foundry, the next thing that the CLI does is it takes your app code from your laptop and it uploads it to Cloud Foundry. And Cloud Foundry stores that in a component called the blob store. And we'll see why it stores your app code here in a little bit, but it stores that information there. And this is really kind of the first phase of a CF push. This is overwriting an existing app or actually pushing a new application as well. So once we've done that, we enter a new phase, a phase called staging. The purpose of the staging phase essentially is to take that application and containerize it, to make it ready to run in a containerized environment. And the component that does that is called a build pack. And so build packs are language specific. So there's build packs for Ruby and Java and Go and Python and a whole host of other things. But the build pack's job, again, is to build that container image. And what it does is it takes your application and it looks at your application and it figures out what runtime dependencies do you have. So if it's a Ruby application, maybe you need Rails. Right? If it's a Java application, maybe you need the JRE, or maybe you need the Python interpreter. It really is dependent on that application. And the output of this build pack process is something that in Cloud Foundry terms we call a droplet. And that droplet gets stored in the blob store as well. And essentially that droplet, for all intents and purposes, it's a container image of your application that's ready to go. And that's really what the whole purpose of that staging phase is. We then enter the starting and running phase of your application. And so to run your application, Cloud Foundry can take that cached droplet. It can create a new container. And that container will have the amount of memory that you specified. It'll have the amount of disk that you specified, and it'll run that container image or that droplet in that container, in a containerization execution engine. So it'll start that droplet, it'll start your container image, essentially start your application, and the container executor is actually doing a health check. It's querying to see when does that application become available. When that becomes available, it's essentially done what we call passing a health check. And when that health check is essentially green, then your application instance is available. And so it can broadcast and basically tell the Cloud Foundry routers that this application name or this application is now available for this particular route and it's available here in this container. So what that allows Cloud Foundry to do is update the route table, its internal route table. And what that means is that your end users of your application can then start get routed to your running application. Now, if you specified multiple instances, then it would just essentially start multiple containers. And when those new containers started and passed the health check, the route tables again would get updated. And now your users could start getting routed to either of your instances. So when you repush your application, it already exists in the space, you repush, you're essentially redoing this entire process. However, if, let's say, we update the build pack as platform operators because maybe the Ruby runtime needed to be patched, all you as a developer need to do is restage your application. When you restart your application, all you're really doing is destroying the existing containers that are running your application and scheduling new ones.